Hi everyone, Morgan here. Today we are looking at page number 6 of the thermochemistry outline for honors chemistry, and we're going to be talking about one of the most fundamental ideas that goes across all of the sciences: chemistry, biology, physics, all of them. And it is called the First Law of Thermodynamics. In a nice basic statement, energy is conserved. And what that means is we cannot create energy, we cannot destroy energy. All we can do is move it around and change it. And if we want an equation, we say delta E equals Q plus W. Q would be heat, W would be work. We introduced those previously. So the change in energy accounts for the heat and work that happen during a specific process. And this idea allows us to introduce the concept of enthalpy. Enthalpy is the heat released in a chemical reaction at constant pressure. Now, it's important to note almost everything we do in a laboratory situation is at constant pressure. The only time you see an appreciable change in pressure over a short period of time is when you're doing something like going up in an airplane or landing in an airplane or taking a submarine down or up quickly. But in a laboratory situation, pressure stays the same all the time, okay? And because of that, we can basically say that enthalpy, in a sense, is just heat. And we've been calculating heats for a while now. Enthalpy is a state function. What that means is it's independent of its it is independent of its pathway. It only depends upon its beginning point and its end point. So for that, we can do what is called products minus reactants, but we don't even do it so much in this class. Okay. Our symbol for delta H looks like the delta H naught. That's enthalpy. Okay? And that little what looks to be a degree sign here tells us that this is happening under standard conditions. And standard conditions means 25 degrees Celsius, which we call room temperature, and 1 atmosphere of pressure. Okay? It just means everything is normal. And pretty much everything we're going to do in this class happens under nice, normal, standard conditions. Okay? Now, I kind of feel obligated to show you a mathematical derivation of this. This isn't something I would necessarily test you on. Delta H is defined as delta E plus P delta V. That's a definition, a mathematical definition. Enthalpy equals the change in energy plus the pressure times the change in volume. And maybe you remember that work equals minus P delta V. We looked at that last week. And from up here at the top of the page, delta E equals Q plus W. So we can write this out as delta E being Q plus W, okay, and add P delta V, which is equal to Q. And then for work, we say minus P delta V, and then plus the P delta V, and those end up canceling. Or that delta H just equals heat, as long as it happens at constant pressure. Okay? Now, very often for anything that's a state function, we imagine, what if we had an equation? A turns into B. This is a balanced chemical equation. Little a and little b are the coefficients of the balanced chemical equation. I could calculate the delta H for this by taking little b times the enthalpy, H naught, for substance B, minus little a times the enthalpy for substance A. Okay? And like I mentioned earlier, it's not something we necessarily do a lot of, but I do feel obligated to show that to you, okay, inside this set of notes, just so you have it there as a reference. Okay, that's page 6 of this outline. Thanks for tuning in.